I love the beats. A little bit too much. Okay, here we go. We want to be able to FOIL or factor out or distribute each term. We want to be able to do our x squared first. So this will be x to the 5th. Then we're going to get plus 2x to the 3rd. And then plus x squared. We're then going to do our middle term. And our last term. This should all be reviewed. This is a pretty simple one. You will have one pretty easy on the test. I saw it already. We want to be able to combine like terms, so I'm going to group my terms together. My x to the 5th is by itself, so I'm just going to drop it. We're going to look at x to the 3rd term, so this is one term here. This is our second term. Take 2 away from -3 gives me just negative x. Then we're going to group our remaining terms and try to just, our x squared would be next. And then our last terms would be minus 6x minus 3. We can't reduce down any of this because there's no terms that are like each other. And we are using adding and subtracting operations that tell us to split it up differently. So we want to just be able to kind of do this slowly as we go along. It's blowing up already. What do you mean? Okay, so here we go. Let's keep on moving. Okay, copy down these two. We do have radicals. We do have radicals. This is another good one. We want to be able to apply these. And we remember that whenever we get a radical, and I'll write this down for you guys if you guys have forgotten, that if we get two radicals a times b, we can join them up to get ab. Or if they're the same, the nth root of the radical x to the nth power just becomes just x. When we do this first one, all I'm going to write out is each term out. This is going to give me square root of x times x squared. I'm going to rewrite that one. We're going to get plus 2x root x plus our last one, which is going to be root x times root x. I think we already see that one. Now we both have exponents and radicals. Not good for us. It's okay, we're going to be able to do this. For me, it's easier just to convert back into exponential form. So I'm going to do each one of these terms. So you guys are going to see here. I'm going to write this as x to the 1/2 x squared. Write the next one as 2 times x to the 1/2. And then what's root x times root x? Just x. This one we already know how to apply. Now for the exponents as a fraction and a regular, what do we do to those? What can we do to them? What do we usually do? If I give you something like this, if I say, what will we do for a squared plus, or no, a squared times a to the third. What would we do with these? Just combine them by adding them up. So that's exactly what we're going to do here, just in fraction form. 1/2 plus 2, it gives me what? 2.5? 2 point, try to give me whole numbers. Try to give me whole numbers. We're going to leave it like that, but then we want to write it as an improper fraction. What's 1 plus 1/2? 1 and 1/2. And then our last one's going to be plus x. What we want to be able to see here is we can actually rewrite them all as improper fractions. So what's the improper fraction for 2.5? 5/2 plus, what's the improper fraction for 1.5? For what? It'd be what? 3/2. Where we multiply the numerator with the whole number, so 1 times 2, and then we add to the top, 3. And then our last one's going to be nice. We just do 2 6. So this would be our answer for it. So we still treat them the same way. We still want to treat them the same exact way. Cool beans? Okay. I'm going to clear this so I can do the other one. Now the other one is just like another FOIL type. So we want to be able to see how we apply here. I'm doing the same exact thing. We're going to go and FOIL out our first term. So first terms is FOIL. This is first. This is going to be our outer. So minus 3 square root of x plus our inners plus 2 root x. And then our last, which is our last term, is going to be, I feel like I wrote that way too close, which would be minus 3 times root x times root x. This one's out a little bit nicer. This one kind of falls a little bit nicer. Our whole numbers will be dropped together. So this is 2. What can we do with the 2 that share the same radicals? What can we do with these two? Combine them. So take a negative 3 plus 2 just gives me 1, right? Just square root of x, right? 1 square root of x or just square root of x, right? And then the cool thing about our last one is we can combine these two. We know that a root x times a root x is going to give me what? X. So negative 3x. Easy. This one's a lot easier, it seems like, right? What's that? Did you guys do this last year? Applying the, no? Okay. Okay. When we start reviewing, I'm going to do a lot of review. So when we come into class, so when we take the team test on Thursday, on Friday, we're going to review. I'm going to give you guys more problems than you need to. I'm going to give you guys more review. So, yeah, put your down. And then I'll probably do a review online. So my YouTube channel will be updated. It's already updated. I just need to make sure you guys get the video, so don't freak out. Okay, here we go. Don't worry about this one. We're gonna skip it. Okay. Do me a favor and copy down those. These are the rules you kind of need to know. These are the special product factors. You'll need to know how to apply these. We'll look at applying them. Sums and products are the same. Difference of squares. All that kind of stuff. And A and B are just terms. We can write them as separate. We can write them as joint. We're just separating them as we have them. Yes. Okay. So let's go ahead and try some of these. Control it. So looking at our special product formulas, we want to see how we're going to identify it. In this case, because it's one term here, this is going to follow from term 2, or special product 2. We're going to get a plus b squared, and this will turn into a squared plus 2ab plus b squared. So as long as you're able to follow that, all you really want to do is plug in. My 3x is going to be my a, and then your b will be 5. So all we're going to do is we're just going to plug those values in. The first one being 3x squared. So I'm going to plug that 3x into there. Plus 2, whatever my a is. So my a is going to be 3x. My b will be 5. And then we're going to go ahead and add our b, which happens to be 5 squared. So these are cool little tricks that you can actually use to solve them out instead of having to separate them and FOIL them all the way. You could just use them directly and it'll work out for you nicely. We're going to go ahead and get 9x squared. 2 times 3 is 6. 6 times 5 is 30. We're going to get 30x. And then our last one will be plus 25. And you're done. So these are cool little things you guys can use in the future. The one to the right for B, if you're looking at it and see how it kind of matches, we have them two separated. We have a subtraction with an addition. And this is actually going to be our rule number 1, which looks like A plus B times A minus B, which is the same terms. And all we're going to get is A squared minus B squared. So this is what we want to be able to use with this. Our A terms being 2x. We're going to plug that into our A squared. And then your B term being the square root of y. So you guys can use these again to make your life a little bit nicer. And all I'm going to do is I'm just going to plug in directly. My A squared happens to be 2x. I'm going to get that 2x squared. I'm going to keep that subtraction. And then my B happens to be square root of y. Or square it. Okay, we're going to simplify out. We're going to get 4x squared. And then the squaring the square root is just what? Just by itself, right? Just a term by itself. And that's it. So we're going to be able to look at some of these problems today. And if they follow one of these, we're going to be able to use them. Or you could just FOIL. Whatever you want to do. It's not going to hurt my feelings. These just kind of help out when you do them, you know, a little bit quicker. Especially with number 4 and 5 where they're longer. Where they're taking it to the third root. You're going to have to distribute once and distribute again. Especially just using these ones. It becomes a little bit more simpler than that. Okay? So here we go. Factoring expression. Writing the expressions as one that is simpler. Okay? So when we're kind of separating them two by product of two terms, we're separating them, we're factoring. If we're going to expand it, that means we're going to write it as a polynomial. So there's two ways we can look at it. You will have to do it both a long and short way. The regular snowflake method works. And you'll also be able to see the longer snowflake method. So we're going to do these two Okay. Okay, here we go. Let's kind of review the factoring portions to it. So we're gonna jump to that. Let's, I'm not even gonna, well, let's look at this, the greatest common factor. The first step that we really want to look at is pulling out the greatest common factor. And that's the term that both of them we can look at in order to separate them, in order to simplify out. Each term, we want to look at the biggest value that is the whole number and term itself. Between these two, the biggest common factor is usually going to be a multiple. So between 3 and 6, the greatest common factor is going to be 3. With our x term, it's going to be the highest value of your exponent. In this case, or sorry, the largest you can make from the smallest exponent. So it's going to be x here. We can rewrite this as 3x and minus 2. The remaining. All we're really doing is we're pulling out the GCF. So this is going to be the GCF. Should remember how to do this. For us, we're pulling out the biggest common factor. It's the largest whole number between the constants, the largest exponent, or the smallest exponent that can be made with all of them. Okay. For this one, let's look at our whole number. So 8, positive 6, and negative 2. Our greatest common factor happens to be negative 2. It's the largest multiple between them. Or in this case, not even negative 2. We'll just make it 2. So we'll separate that. Between our x's, it's the smallest polynomial that we can make, or the smallest exponent. So 4x squared plus 3x and x, which we can now pull out a x. And then for our y's will be y squared, y to the third, y to the fourth. So in this case, we're looking at y squared. When we reduce everything down, we want to see what's remainder, or divide everything out, or subtract everything out. We're given for our full numbers. For our first one is going to be 4. We're taking 1 out from x to the 4, so it's going to be x to the third. Our y squared is going to be completely removed out, so we have nothing to put in there. We're going to do plus 3. We're going to take 1 away from our x third, 2 away from our y third. Just be y. We're going to be left with our negative 1 for our 2's. Our x is taken out completely, and we're left with y squared. You can leave it as y squared. If you want to leave it like that, I see what you mean. You can leave it as just y squared. I'm going to move this over just a little bit. So I'll move this up here. Now, the crazy thing about this, we can actually look at it as two terms. For this problem that you see down below, is we're actually getting a full term here because those two products are being multiplied, and we're getting a final term here. Now, the commonality between those two that we can look at is the one thing that they share is x minus 3 and x minus 3. So we can actually pull that out almost like we're unfactoring it. We're going to pull it out to the front. So this is going to become x minus 3 to the front of it. And I'm going to use brackets to kind of rewrite this. This is 2x plus 4. And then because this gets eliminated, we still have something that looks like that. So if I were to redistribute it, it would look like my original problem. Can we reduce down the things that are in the brackets? What would it become? Just 2x minus 1. Our whole numbers would be added. We would drop down our term, and we're done here. We kind of pulled out our factor. This is really what they call it is factoring by groups, by grouping. We're pulling out just a group of terms together. So that's another way we could pull out a GCF for this, even though it's really not a term by itself. We could still pull it out. Yes. The negative, for which one? The first problem on the left? There's no y in this one. Oh, negative 5? When we have this, right, we're just given terms. You could think of it as eliminating your parentheses, right? I can eliminate these parentheses because they don't really help me out. What is 4 plus negative 5? Gives me negative 1. All I'm doing is I'm just adding up the terms inside the parentheses. There's no operations that are being done, so we don't have to do really anything with it. Did I need the parentheses? No, to start out with, but I'm just grouping them so you can see them. Okay. Here we go. Factor. Okay. One thing that we're going to look at for our factor terms, this is one where A is different. I'm going to put an A up in this factor term up here so if you guys can copy this part down. That's going to be helpful. A lot of you guys should remember how to do these. We should be pretty good at these. We do the snowflake method. This is the regular snowflake method. Whatever is being multiplied, we keep on top. And this is being multiplied would be on top. Our B is going to be on the bottom. So B term. We need to find out what adds up to AC or multiplies to AC but adds up to the B term. So we'll put adds. Adds to B term. This should be basic factoring. You guys remember how to do these ones, right? Yeah? Creating my snowflake with this. If you want to put a 1 in front of there, you can. What multiplies to give you 12 but adds up to give you 7? It'd be what? 4 and 3 and 4, right? These become our terms at the end of them. So this is going to have 3, which would be x plus 3. Then my 3 comes in. And then the 4 is going to be my final term, which will be x plus 4. And that's our factored We're done. Doing it again, we have multiplies on top, our first and last, so -6 and 1. Adds up to 1 would be what? How about this? Negative, or how about +3, -2? +3, -2 is going to give me the factor terms of +3, so it's going to give me x plus 3. And then my last term is going to be x minus 2. Yeah, minus 2 comes into play. Remember how to do these? Okay. Cool. So I'm going to skip this, and we're going to go with the more trickier ones. We don't need to do C. We don't need to do C. If you want to have the answer, it'll be x minus 3, x plus 1. If you want it, you can have it. There it is. Okay. The more complicated ones is what you guys will have as well. So we're going to skip this as well. We would just pull out the regular factors. We're going to skip that. Factored by grouping. So we need to do this one. So we're going to factor out by grouping. This is one that you will have on the test. Okay, I'm hoping you guys remember how to do this. Is it okay to see like that? Can we see it like that? Okay. What I'm going to do is I'm going to separate them down the middle because I'm looking at terms that are x's and I'm looking at terms that are whole numbers. So if I separate them, just separate them down the row, and we're going to pull out the greatest common factor between both groups. So looking at x to the third and x squared, what is my greatest common factor? X squared. So if I pull out that greatest common factor, x squared just becomes x plus 1 for that first group. I know it kind of seems weird, but we're going to be doing this. That last group, what's the greatest common factor between 4x and 4? 4. So we're going to pull out that 4, and now this becomes just x plus 1. And it now gives me my grouping that I'm actually going to be able to pull out. So I'm going to separate them by terms by themselves. So from those groups now, we're going to pull out the greatest common factor. In this first group, we're going to get x plus 1, which is one term here. And then our last term is just going to be x squared plus 4. So those are our two factor terms. If we wanted to, we could separate it. I don't think we can with this one. The x squared plus, no, this one doesn't really have one. Minus 2 plus 2 doesn't work out. If it was minus, we'd be able to factor it one more time, but we can't do that. So this is one term that we're done here. Showing you one more time, I'm going to split them again. Split them down in half. Greatest common factor between 4x to the third and negative x squared? Be 4x squared. We're going to be left with just x minus 2. Between the terms to the right will be our negative 3. Look at that. Look how nice they're going to look. What's the greatest common factor between these two? Is our x minus 2 and our x minus 2. So we're going to get x minus 2, 4x squared minus 3, which is going to be our two factors. Did your teachers go over this last year? Yeah? Is it good just to refresh on it? Does it, yeah? Okay. Cool. How much more time do we have in here? 3 minutes? Let's try to do just 2 more and then we're done. Or just one of them, so just because this should all be refreshing. We're going to skip this. Factoring by 2 terms. Factoring by 2 terms. So these are the advanced snowflake method. So almost the same thing, except we make another line here where we put our AX on top of these. Our A times C is still going to go on the top. Our B is going to go on the bottom. And whatever numbers we come up with are going to be in our groupings here. Yeah, if you can pass those out for me, Antonio. Thank you. Okay. So I'm hoping you guys remember how to do this. This was probably one of the more trickier ones that we've done. But it shouldn't be too bad. If I'm going to follow this kind of thing, what is A times C? Negative 30. We're going to put 6x on top. That's going to be part of our new factors. What adds up to 7? Negative 30, but adds up to 7. 10 and 3. So we're going to have 10 here, 3 here. This will be minus 3 plus 10. Now, we're getting our factors here. We're getting our factors here, but we also want to be able to reduce it by, just reduce one of them. Reduce just one of them. In this case, I can go ahead and, for my right-hand side, it seems to be a little bit easier. I'm going to reduce it by 3. So this is going to become 2x and minus 1. So this is one of my factors, and my last one is this factor. Or can we reduce that too? Can we reduce that? We've got to reduce both of them. Sorry. We've got to reduce both of them for this one. So that can be reduced down to what? 3x and 5. 3x plus 5. 2x minus 1. Cool beans? Your homework problems are on there. I'm going to go and do this last one just so you guys have it. You guys have a good day, guys. Top is 24. We're going to have 8x and it. Oh. Put the quizzes back over there. Whatever you guys don't finish, it's going to be okay. I'll give you guys leniency for this one. We'll see you guys. 604. Thank you, bud. Thank you. We have 8 and 3. You guys too. Yes, sir. Yeah, if you want to. Finish it tomorrow morning. Just come in early. Yeah, you should be here early. I'm going to start truanting you guys. Yeah, go for it.